Compressed natural gas, a standard for safety. In the early 1990s, NGV Industry brought together industry stakeholders, research organizations, and regulatory agencies to start the development of a standard for CNG cylinders. The standard was based on existing pressure vessel standards and placed no limitation on materials and methods of construction, considered both internal and external container environments, and most importantly, incorporated a certification process for design, manufacturing, and quality control. The standard ANSI NGV2 is now in its fourth edition. At the same time, the U.S. Department of Transportation's National Highway Traffic Safety Administration published regulations to cover the use of CNG cylinders as vehicle fuel tanks under FMVSS number 304. Regulations covering the fuel system integrity in FMV SS 303 will be discussed when we cover crash testing of vehicle fuel systems. One of the important design considerations for CNG cylinders is weight reduction, especially where large volumes of fuel need to be stored. Weight reduction of cylinders has been achieved by several means and has led to 4 type classifications of cylinders. The Type 1 cylinder is all metal and has achieved weight reduction by using higher strength materials and production technologies. Composite cylinders use a combination of materials for construction. Type 2 cylinders have a thinner metal body and are hoop wrapped with resin-impregnated high-strength fibers such as glass or carbon. The Type 3 cylinder uses a thin metal cylinder and is fully wrapped, including the dome ends, with the same high-strength fibers and resin. A Type 4 cylinder uses a non-metallic liner and is fully wrapped with resin-impregnated fibers that can take the full stress of its compressed gas. As we stated earlier, the pressure vessel or cylinder standards were originally developed for industrial gas cylinders, not specifically for NGV applications, and they included production tests such as hydrostatic test and leak test of each cylinder and batch tests such as burst test, cycle test, and coating thickness and adhesion test. Many of those tests have been carried forward to NGV applications. Additional design qualification tests were added to address specific NGV conditions, including ambient cycling test, environmental test, extreme temperature cycling, hydrostatic burst test, composite flaw tolerance test, drop test, bonfire test, penetration test, accelerated stress rupture test, permeation test, natural gas cycling test, and the leak before brake test. The bonfire test is essentially a fire test that replicates a vehicle fire. The cylinder and the pressure relief device as part of the safety system are exposed to a fire, and the pressure in the cylinder is released by the PRD before any possible failure of the cylinder. The drop test is designed to replicate potential physical impact damage to the cylinder as may happen in a vehicle accident. The cylinder is dropped from a specific height onto the dome in one test and onto the sided wall in another. The cylinder must still pass the designated burst test with no degradation to pass the drop test. The penetration test uses gunfire to replicate through-wall damage in an accident. The cylinder will release the gas at the penetration point, but will otherwise remain intact. FMVSS 303 requires OEMs to crash certain vehicles to show the integrity of the CNG storage system on vehicles. In this video, a crash test for a school bus involves an approved moving contoured barrier impacting the side of a CNG school bus at about 29 miles per hour. To pass the test, there must not be a leak on the fuel system. The next test run shows the rear end impact. The frame of the vehicle absorbs the impact, and there is some movement of the fuel system, but as before, it must not leak any of the stored CNG to meet the safety requirements. The safety record of CNG vehicles has been exemplary. CNG fuel systems and cylinders, when designed, manufactured, installed, and maintained by the existing codes and standards, have a history of safe and reliable operation for their expected life. There are well over 130,000 natural gas vehicles operating in the U.S. today. With the expected continuation in the price differential between natural gas and liquid fuels, there will be accelerated growth in the use of natural gas vehicles in the years to come. The safe and reliable compressed natural gas cylinder is an important part of this transformation to natural gas as a vehicle fuel.